All right, let's jump right in. Today we're talking about the engine behind the entire AI revolution that we are all living through. Large language models. You've probably heard the term LLMs thrown around a lot. Well, if you've used a chatbot or a translation tool, or even just a modern search engine, you've already used one. So let's break down what they actually are, how they work, and why they're such a big deal right now.
So, why should you care? Because this isn't some abstract, futuristic idea. It's already here. According to Forbes, a staggering 66%, that's two-thirds of us, are already using AI on a regular basis, a lot of the time without even realizing it. And the speed of adoption is just incredible, especially when you look at the next generation.
I mean, look at education. That same report from Forbes found that 92% of students are now using generative AI tools. Think about that for a second. It is fundamentally changing how people learn. And it's not just in the classroom. Businesses are in an all-out sprint to keep up. Yep, it's the exact same story in the corporate world. The 2025 Stanford AI Index report shows that 78% of organizations are now actively using AI. That's a huge jump from just 55% the year before. The race is definitely on. Okay, so we've established that AI is everywhere. But what actually is the engine driving all of this? How does a computer go from just a mountain of data to having what feels like a real conversation? At its core, a large language model is an AI that has been fed just an unbelievable amount of text. We're talking books, articles, websites, all to learn how to understand and generate language that sounds like us. The absolute best analogy is to think of it as the most powerful, souped-up autocomplete you can possibly imagine. But instead of just finishing your sentence, it can write you a poem, debug your code, or draft a business plan. The way they're trained is, conceptually pretty simple, even if the scale is mind-boggling. First, the model just gobbles up a massive dataset, a huge slice of the internet. Then it meticulously churns through all that text to find patterns, not just grammar, but the subtle relationships between ideas and words. And finally, after all that learning, its main job boils down to one thing: predicting the most probable next word in a sentence. That's it. By stringing those predictions together, one word at a time, it creates everything we see. But it's so important to remember that this isn't just magic happening in some digital cloud. It has a very real, very physical footprint. These models are trained on trillions of words, which requires thousands of super powerful, specialized computer chips running 24/7. The resource drain is just staggering. In 2025 alone, AI's electricity consumption is projected to be about the same as the entire United Kingdom. And get this, just a single average conversation with a chatbot can use about half a liter of fresh water just to keep the data centers from overheating. So these things are incredibly powerful, which of course leads to the billion-dollar question: are they actually getting smarter than us? To figure that out, researchers use these standardized tests called benchmarks. And the results? Well, they're both amazing and, frankly, a little bit deceiving. So what you're looking at here is AI closing the gap on human expert performance at a frankly terrifying speed. On really complex benchmarks, we're talking competition-level math problems, PhD-level science questions. The latest models aren't just hitting the human baseline. They're starting to blow right past it. The progress year over year is just off the charts. And if you want a perfect example of superhuman performance, look no further than coding. The human eval benchmark is a notoriously difficult test of a model's ability to write working code from scratch. A few years ago, getting a good score was a breakthrough. Now, models like Claude 3.5 Sonnet can score a perfect 100%. That means it's writing flawless solutions to problems that would stump a lot of very experienced human programmers.
But, and this is a really big but, those incredible benchmark scores don't tell the whole story. Because when you move from these neat, tidy test questions to the messy reality of the real world, like, say, a really long, complicated document, a pretty serious weakness starts to show up. So you have to ask yourself, right, are these perfect scores on isolated tests really telling us the whole story? Can these models keep up that level of performance when the task gets bigger, messier, and a whole lot more complex? And this brings us to a really key idea called the context window. The easiest way to think about it is as the model's short-term memory. It's how much information it can hold in its head at any one time. And right now, all the big tech companies are in this crazy race to make these windows gigantic, with some claiming they can handle millions and millions of words at once. And here is the reality check.
What this research shows is that while the advertised context window might be huge, the effective one, the one that actually works reliably, is a whole lot smaller. You see it right here. As you feed these models more and more information, like a long financial report, their accuracy just collapses. They start forgetting key details, making things up, and getting confused long before they hit that supposed maximum limit. So the big takeaway here is pretty simple. There's a huge gap between what these models can do in a controlled lab setting and what they can do reliably out in the wild. When it comes to complex jobs that need a deep understanding of a large amount of information, this limitation is one of the biggest hurdles that researchers are trying to overcome right now. So this brings us from the tech to the society it's reshaping. This is an incredibly powerful tool, and like any powerful tool, it holds the potential for both unbelievable good and pretty significant harm. The path we take from here is going to define our future.
And this right here is the central dilemma. On one hand, you have AI being used to design life-saving medical workflows that help doctors spot diseases earlier. Amazing. On the other hand, the exact same underlying technology can be used to create fake images and spread misinformation designed to sow chaos and influence elections.
And because the stakes are just so incredibly high, what we're seeing now is a global race to figure out the rules of the road. Governments all over the world are scrambling to build guardrails, trying to find that perfect balance between encouraging all the good stuff while protecting people from the potential downsides.
Right now, there are kind of three main playbooks emerging. You've got the European Union, which has gone for a big, top-down approach with its AI Act. It puts AI into different risk categories. Then you have the United States, which is using more of a bottom-up, decentralized model. A presidential order basically tells existing government agencies to make up rules for their own little corners of the world. And then there's China, which has this hybrid system that's very centralized and focused on social stability, but also on pouring resources into national champions to innovate.
So, as we've seen, large language models aren't just a fascinating piece of tech. They are a massive societal force. They're getting more capable at a stunning rate, but they have very real limitations and very real costs. The fundamental question we're facing isn't if AI is going to reshape our world. It already is. The question is whether we can get our act together and steer it wisely. The technology is here. The real work is just getting started.